What is the fastest way in Python to find if a string matches any terms in a list of words, phrases, Boolean ands? I am trying to find a fast way in Python to check if a list of terms can be matched against strings ranging in size from 50 to 50,000 characters. A term can be a word, e.g. apple. A phrase, e.g. cherry pie. Boolean anding of words and phrases, e.g. sweet pie and savory pie and meringue. A match is where a word or phrase exists around word boundaries, so I currently have about 40 terms, most of them are simple words. The number of terms will increase over time, but I wouldn't expect it to get beyond 400. I'm not interested in which terms a string matches, or where in the string it matches. I just need a true/false value for a match against each string. It is much more likely that no terms will match the string, so for the 1 in 500 where it does match, I can store the string for further processing. Speed is the most important criteria, and I'd like to leverage the existing code those smarter than me rather than trying to implement a white paper. Smile. So far the speediest solution I've come up with is the regex winds up as. So all the terms are ORed together, cases ignored, the words/phrases are wrapped in \b for word boundaries. The Boolean ands use lookahead so that all the terms are matched, but they do not have to match in a particular order. Time equals results. Without the lookaheads, EA. The Boolean ands, this is really quick, but once they're added the speed slows down considerably. Does anybody have ideas on how this could be improved? Is there a way to optimize the lookahead, or maybe an entirely different approach? I don't think stemming will work, as it tends to be a bit greedy with what it matches.
The Boolean and regex with the multiple lookahead assertions can be sped up considerably by anchoring them to the beginning of the string. Or better yet, use two regexes, one for the ORed list of terms using the read.search method, and a second regex with the Boolean anded list using the read.match method like so. The effective regexes for this data set are Note the second regex effectively has an anchor at the start since it's being used with the read.match method. This also includes a few extra, minor, tweaks, removing unnecessary capture groups and changing the greedy.star to lazy. This solution runs nearly 10 times faster than the original on my Win32 box running Python 3.0.1. Additional, so why is it faster? Let's look at a simple example which describes how the Enfa regex engine works. Note that the following description derives from the classic work on the subject, Mastering Regular Expressions, 3rd edition, by Jeffrey Friedel, Ma3, which explains all this efficiency stuff in great detail. Highly recommended. Let's say you have a target string containing one word and you want a regex to see if that word is apple. Here are two regexes one might compose to do the job. If your target string is apple, or applesauce or apple pie etc., then both regexes will successfully match very quickly. But if your target string is say, orange, the situation is different. An N for regex engine must try all possible permutations of the regex on the target string before it can declare match failure. The way that the regex engine works is that it keeps an internal pointer to its current location within the target string, and a second pointer to a location within the regex pattern, and advance these pointers as it goes about its business. Note that these pointers point to locations between the characters, and to begin with, the target string pointer is set to the location before the first letter if the target string. Re1, the first token in the regex, is the start of string anchor. This anchor is one of the special assertion expressions which matches a location in a target string and does not actually match any characters. Look ahead and look behind, and the \b word boundary expressions are also assertions which match a location and do not consume any characters. OK, with the target string pointer initialized to the location before the first letter of the word orange, the regex engine checks if the anchor matches, and it does, because this location is, in fact, the beginning of the string. So the pattern pointer is advanced to the next token in the regex, the letter A. The target string pointer is not advanced. It then checks to see if the regex literal matches the target string character O. It does not match. At this point, the regex engine is smart enough to know that the regex can never succeed at any other locations within the target string, because they can never match anywhere but at the start. Thus it can declare match failure. Re2. In this case, the engine begins by checking if the first pattern char matches the first target char O. Once again, it does not. However, in this case the regex engine is not done. It is determined that the pattern will not match at the first location, but it must try and fail at all locations with the target string before it can declare match failure. Thus, the engine advances the target string pointer to the next location. Friedel refers to this as the transmission bump along. For each bump along, it resets the pattern pointer back to the beginning. Thus it checks the first token in the pattern A against the second char in the string, R. This also does not match, so the transmission bumps along again to the next location within the string. At this point it tests the first char of the pattern A against the third char of the target, A, which does match. The engine advances both pointers and checks the second char in the regex P against the fourth character in the target N. This fails. At this point the engine declares failure at the location before the A in orange and then bumps along again to the N. It goes on like this until it fails at every location in the target string, at which point it can declare overall match failure. For long subject strings, this extra unnecessary work can take a lot of time. Crafting an accurate and efficient regex is equal parts art and science. And to craft a really great regex, one must understand exactly how the engine actually works under the hood. Gaining this knowledge requires time and effort, but the time spent will, in my experience, pay for itself many times over. And there really is only one good place to effectively learn these skills, and that is to sit down and study Mastering Regular Expressions, 3rd edition, and then practice the techniques learned. I can honestly say that this is, hands down, the most useful book I have ever read. It's even funny. Hope this helps. 8 carat.
I am going to give a partial answer here, but why don't you split the test and matching strings on word boundaries and build a set? You can intersect sets very quickly, and if the set matches then you can do the expensive regex test.
If you want to see more, please consider subscribing.